Welcome back, everybody. Today we're going to talk more about outliers and specifically about how you figure out what values are outliers when you're looking at a box and whisker plot. In terms of our data cycle, we're really moving into more of the interpretation. So we're using our box and whisker plot, which we already know how to draw, and then we want to figure out what influence the different outliers have, if there are any. In our last lesson, we talked about the three different types of distribution. So we either have skewed data, and we talked about how it can be positively or negatively skewed, depending where the mean is relative to the median. And then we saw that when the mean is roughly equal to the median, we call that symmetrical, because there's equal pull coming from both directions. We said that skewness, or this imbalance in the data, is caused by the effect of outliers. So let's look into that a little bit more today. So what's the big deal about outliers? Why do we care so much? To answer this question, I want to look back at the example that we did last time, where we have different motorists going past the school gate. So some of them go quite fast and some of them go not so fast. Right. We can see straight away from looking at these data that there's one value that's quite a bit lower than the others. Can you see what it is? Yeah, it's 18. 18 is quite a bit lower. The next one closest to it is 40. And then they go up from there. Okay, the maximum being 82. Okay, so what's the big deal about outliers? We saw last time that if we drew our box and whisker plot with the outlier, we'd have a skewed box and whisker chart that looks like this, where the data are negatively skewed because this 18 is pulling down the mean. So we saw that the mean was at 60.2. Now let's see what the data would look like if we take that outlier out of our analysis. Right. So without the outlier, again I have my number line, and look what happens to our box and whisker. The next lowest value was at 40. So already I can see that the data looks quite a bit more symmetrical. Just by excluding that one data value, that 18, I've created a little bit more symmetry in the data. Let's look at it a little bit more carefully and calculate the mean. The mean now is at 30.7. So again, much closer to the median, meaning I've created more symmetry in the data. Now, what's important here is that I didn't just eliminate the value of 18. I didn't just throw it away. What I did with it was I excluded it, but it's still part of the data set. So I indicate that using this star, okay, showing that there's an outlier that I'm acknowledging, but it's not forming part of my box and whisker. So figuring out what to do about outliers is a huge part of statistics and statistical analyses. Remember that outliers are exceptionally high or low values. You can think of them as extreme values. And they create this skewness or this imbalance in the data. The problem with that is that it makes the mean less reliable, because we've seen in numerous examples already that the mean is really affected by these high or low outliers. The mean is most useful when we have symmetrical distributions. And we know that symmetrical distributions are when the mean and the median are more or less equal. So what do statisticians try to do to create this balance? Well, just what we did in the last exercise. They often exclude outliers when they're doing their analysis. That doesn't mean that the outliers fall away from the data set. They're still part of the data set. It just means that they are excluding them to look at the bulk of the data without these extreme values. Now for you guys in school, in high school, you will only exclude outliers when you're told to do so. So another way of saying this, always include the outliers unless the problem instructs you to do otherwise. You'll see this today in your homework. So here's a pop culture reference for all you Star Wars lovers. I realize this movie came out in 2002 and it probably predates most of you, so You might not even know who this is. But anyway, Count Dooku says, when you run your main analyses without checking for skewness or outliers, brave but foolish. And I think that's how most statisticians feel. Okay, so what causes outliers? Chance phenomenon, measurement or recording error, or experimental error? Let's look at an example of these three types of causes. Okay, back to our racing cars outside the school gates. Here's our box and whisker plot, again without the outlier included in our analysis, but the outlier is still here with a star, so we are acknowledging that it still exists as part of the data set. Okay, what might have caused this? And this is part of what statisticians do when they exclude an outlier. As part of their analysis, they still explain why they excluded it or why it might have been an outlier in the first place. So let's see. What causes outliers? Chance phenomenon. Maybe there was just an old, shame I'm being ageist, maybe there was just a grandpa or a grandma who drives very slowly and happened to actually be going 18 kilometers per hour. That's possible. So that's a chance phenomenon. It's a real reading. There's nothing inaccurate about it. It's just unusual. There could be a measurement or recording error. So let's say we were taking these values using a radar gun. Maybe there was a problem with the radar gun where it read inaccurately. Or maybe whoever was taking the values, it was supposed to be 78 and they wrote 18 by accident. It happens. An experimental error. This is like if there's just a problem with the experiment. So in this example, it could be like if the cyclist is going past and the radar gun picks up the speed of the cyclist rather than an actual car. Here's the part you've all been waiting for. How do we figure out what's an outlier and what's just a low or high value? Okay, we need to determine something called the lower and the upper fence. The lower fence is the first quartile, and you know how to figure out your quartile. So the first quartile minus 1.5 times the IQR, which you know stands for the interquartile range. Okay. The upper fence is quartile 3 plus 1.5 times the interquartile range. So what this is basically doing is it's basically giving us some sort of boundary in which we will accept below quartile 1 and above quartile 3, depending on the range of this middle 50%. So we're saying anything inside this fence we accept as sort of a normal value. Anything outside the fence is an outlier. And this is just one way that statisticians might determine outliers. But like I said before, there are actually lots of different ways. Okay. All right, so your textbook talks about the interval. So all that means is that we're taking the lower fence and the upper fence and saying that everything in between this interval, and including, because it's square brackets, everything in between this is not an outlier, so is acceptable, and anything outside the lower fence and the upper fence is an outlier. Just one example today of how this works, how to identify outliers. In our last lesson, we looked at the marks out of 35 from a trig test, and I said it may or may not be my grade 11 class this year. Obviously it is, you guys know that. But I have a big confession to make. I actually hadn't completely marked one of the questions. So, sorry very much to my class. Your marks were actually a little bit higher than I reported last time. So you can tell your friends that if they chirped you, that they must just be quiet. Okay, so this was the original box and whisker. We're canceling that one. And I'm saying, oops, sorry. And this is the new box and whisker. So we can see that instead of having a mean of 18.3, my new mean 19.2, and the median has gone up 18.5 to 19.5. So we can see that everything is sort of shifted up by roughly 1 mark, except the minimum value, whoever this is, we need to have a chat. Okay, so we're using this to identify outliers in the data set. All right, so here's our box and whisker again. Technically, we don't really need to draw the box and whisker, but I want to visualize this with you so that you see what we're actually doing here when we figure out our lower and our upper fence. Okay, so the first thing we need to do is work out our interquartile range. Take quartile 3 minus quartile 1. And remember, you're going to be doing the legwork of figuring out what these quartiles are. So that's putting the data in ascending order and figuring out the various middle points and median values of the different segments. Okay, so the IQR here is 6. We then work out the different fences. So the lower fence, quartile 1 minus 1.5 times the IQR. Substituting in, I get the lower fence is at 8.5. So I'm going to draw that with a dashed line on my box and whisker plot. The upper fence is quartile 3 plus 1.5 times IQR. Substituting in there, we get an upper fence at 32.5. So I can see that my original box and whisker contains some outliers because there are values that are outside the boundaries of these two fences. So anything below 8.5 is an outlier. So let's try and highlight those ones. Anything below 8.5, so scanning the data, here's an 8, so that's below 8.5. There's a 5, and there's a 3. So all of these are outliers. Then anything above 32.5, and I think that's just 33. So I have 4 outliers. 3 of them are exceptionally low values, and 1 of them is exceptionally high for this data set. Okay, so I've identified my outliers. Number 1 is done. Let's look at number 2. Now the second question asks us to calculate the mean and median without the outliers. So this is an example of a question that's telling you to exclude the outliers. I've shaded them in grays, but I didn't get rid of them completely because they're still part of the data set. It's just that I'm excluding them for this part of the analysis. Right. So you know how to work out the mean by now. Take the sum of the values, divide by the number. So there are now 16 values because I've excluded 4. And my new mean is 20.9. The new median, you know that you'd put the values in ascending order and count in to figure out the middle value. In this case, because it's an even number, 16 values, you'd have to take the average of the 2 middle values. Okay. If you have questions on that, ask your teacher during Q&A. Your teacher can also show you how to do it on your calculator, which may be valuable. Okay. So the median here, the new median is 20.5. Right. Number 3 says, what effect did the removal of the outliers have on the mean and the median? Well, let's look at our old mean and our old median. The old mean 19.2 and median 19.5, and the new values are a bit higher. So by excluding those values, I've actually gotten a little bit better idea of the mean and the median for the bulk of the class. So we've taken away those 3 relatively low values and the 1 relatively high value. And this just leaves the 16 values that are sort of more normal, more representative of this class. And for me as a teacher, this can give me a better idea of where the mean actually lies, all right, where the median actually lies. So these are now a little bit more accurate reflections of the majority, okay? Just to be complete, we have finished this question, but just to be complete, I wanted to compare, this is our old box and whisker with the outlier. And then we figured out the fences, so we excluded some of those outliers. So here's our new box and whisker. Okay, so notice what's happened. I now have a minimum value at 14, maximum at 32, we can see that this box and whisker is a little bit more symmetrical. The median and the mean are still relatively close. They were relatively close to start with, okay? So the data was relatively symmetrical at first, but it had these long whiskers. So there were some extreme values on both ends that were still pulling, so still making the mean and the median relatively equal. But now I just have the box and whisker grouped a little bit closer together. So it's just a little bit more easy for me as the teacher to read this. Remember that I've shown the outliers that were excluded using these stars. Okay. Now, I want you to pause the video here and figure out, is 18 actually an outlier based on the definition that I've given you before and the formula? Pause the video and find out. What do you think? So you should have figured out, we know that this is a lower outlier. So we only really have to figure out the lower fence. The lower fence is quartile 1 minus 1.5 times the IQR would give you 16.25 here, which is down here. So technically, based on this definition that I've shown you today, 18 actually lies in our sort of happy range. So according to this definition, 18 is actually not an outlier. Oh dear. What I want you to take away from this is, the way that I've shown you here is the way that the book does it is what you need to know for grade 11, okay? But there are actually lots of different ways to figure out what outliers are. So as you progress in your statistics journey, if you do carry on at varsity level, you learn a lot of different methods, and you kind of have to pick and choose and work out for your own analysis what you want to include and what you want to exclude. You only have 3 exercises for homework tonight, so E, F, and G on page 319. For G, you need to remember how to read a stem and leaf plot. So if you need help, I've included a little diagram here to remind you. You also need to know how to determine quartiles from a stem and leaf plot. So if you need, you can click this link in the notes and it will take you to my grade 10 video where we talk about that. Okay, good luck. Ask your teacher if you have any questions.